The Antarctic, a few days ago, hit an all-time record high ever, and the sea ice in the Antarctic was also a record low. And losing sea ice in both poles is very bad because that loses our albedo reflection. We had a 40 degrees higher than what the scientists say is normal in the Antarctic. 40 degrees higher.
Hello, everyone, and welcome to another Climate Emergency Forum. If there's a climate emergency, we've got it covered. And, it seems like there's no shortage of climate emergencies. Our subject is perilous polar heat waves. We've seen temperatures anywhere from 50 to 70 degrees Fahrenheit above what they should be. And later on in the program, I'm going to let Paul speak to that. I don't have the specifics, but what I will say, anyone can look at that and say, wow, this heat is unprecedented. It has been unprecedented and it's frightening. Those numbers are frightening. And as Antonio Gutierrez, the UN Secretary General, has said, countries are sleepwalking their way to climate catastrophe. I'm just going to give a quick breakdown of what this means. The climate hazards have increased significantly over this past decade. I mean, what we've seen is people who've been displaced from their homes, food shortages, and water shortages, the very sustenance of life. And the thing is, if warming isn't slowed, the dangers are going to multiply. Increased wildfires, mass tree die-offs, drying of bogs, and thawing of permafrost. These are all going to release more carbon dioxide into the air. And this is why the warming poles is so perilous. It isn't just that this whole biosphere is melting, changing rapidly, but the carbon dioxide and methane that will be released is going to create a positive feedback loop for even more warming. And we haven't done enough to adapt. Even the rich countries haven't done enough to adapt. Adaptation seems to be, an afterthought. I mean, we have built seawalls, some countries, to defend against rising tides. But what that often does is push these rising tides further down shore. So it seems that for every solution we have, nature comes with a way to outwit us, and nature does. I mean, we just love to think that we're so brilliant, but I'm sorry, the law of nature cannot be overturned. And the thing of it is, it's not just what we're doing to the world, to the planet, to living sentient beings, but also what we're doing to humanity. And the costs are prohibitive. Everyone says, well, we can't afford, we've got a few ice caps melting somewhere where I don't live, but I don't want my taxes to go to something like this. But you know what about your taxes going to people's health, to people who are dying because of bad air quality that is continuing and continuing? What about the fact that people's mental health is suffering tremendously? Believe it or not, this is really true. Climate grief, climate anxiety is an ever increasing issue that doctors and psychiatrists and therapists are seeing. This is just the beginning. I will say the tip of the iceberg. So it's truly scary. I was reading an article in the Times, I believe it was this morning, about the youth of America who are calling older people, well, they're no longer calling them boomers, they're now calling them doomers. And they're saying, we have to do something. And I respect the youth of America for picking up plastic off of beaches. But, we have to have people understand that it's not just picking up trash. I love picking up trash. I do it when I go to the beach, but there's nothing I can do about the microplastic that's in the ocean. The microplastic that's in the air. We have to stop consuming. Our polar ice caps are melting, and that will affect us directly.
We need our planet to stay the same. If we continue to change our planet, it is very, very, very serious. And I agree, this is absolutely not being taken seriously enough. So to keep the planet the same, we need the ice. Once we start losing ice, we have a completely different planet. We've already actually got a completely different planet. Humans have never lived on the planet that we live on now. It's a no analog situation, and that is very, very serious. Now, sure, with the melting of the ice sheets, the sea level's rising, and that is happening much, much faster than ever anticipated. I mean, like hundreds of years faster, but it's still very, very slow. The problem is not so much the sea level rise, the problem is losing the amount of ice. And the amount of ice that we lose, the area that we lose, and we're losing area all the time, in both poles, in fact, now, then the planet gets hotter. The scientists warned us about this for decades. The one thing that we had to make sure didn't happen was losing the area of ice, because that's a shield for the planet, which allows life to prosper as it does on this still pretty wonderful Earth. The Arctic, of course, as we all know, is in a rapid decline of sea ice area, and even more so of volume and thickness. There's hardly, in the summertime, there's hardly any old ice now at all. It's all thin. But I want to address the Antarctic first, because this was the huge, huge shocker. I mean, all the scientists just basically couldn't believe this, right? So the Antarctic, a few days ago, hit an all-time record high ever. And the sea ice in the Antarctic was also a record low. And losing sea ice in both poles is very bad, because that loses our albedo reflection. We had a 40 degrees higher than what the scientists say is normal in the Antarctic. 40 degrees higher. The numbers get a bit confusing, because this is still minus 11.8 or something like that. But for this time of year in the winter in the Antarctic, that is balmy. That is crazy. It's never, ever, ever been like this before. So the big story, which made the headlines, was both poles in March were at record highs. Highs in March they'd never come close to before. So, you know, the 40 degrees C in the Antarctic, in some regions, not the complete Antarctic, and 30 degrees in some regions higher than normal in the Arctic. It was raining in the Arctic for a while. Terribly, terribly serious. We have to keep our ice, folks. We have to keep our ice. We need it. It's our security and our future security. So over to you, Paul, on this crazy event.
Yes, thank you, Peter and Regina. So if you look at the numerous articles that have appeared in things like The Guardian and Washington Post and New York Times, they've all been talking about this massive heat wave at both poles simultaneous. And that's the thing that is really surprising to most scientists, because generally, you know, we've had heat waves at one pole or the other at different times, but it's the combination, the simultaneous combination of these record-setting heat waves at both poles that is what is surprising most scientists. And, you know, I have to say that I'm not surprised at all that this is happening, because if you look at the overall climate system, Peter's been saying we have to preserve the ice, and that's absolutely true in order to maintain a stable climate. And we're certainly, we're well beyond a stable climate now, because we've already lost a significant amount of ice, mostly in the Arctic. That's where the focus has been in the Arctic, but also it's not just the sea ice loss, it's a loss of snow cover over the permafrost. And of course, snow reflects lots of sunlight, as does ice. And when you lose the snow cover over the land, you have the dark tundra, permafrost, et cetera, exposed in the Arctic. And so the Arctic is becoming a much darker place. Physically, it's becoming darker. The overall Arctic is not reflecting as much sunlight. Now, up until recently, the effects in the Antarctic were not as extreme as what we've been seeing in the Arctic, but this is starting to change quickly. We're starting to see lots of calving of ice sheets from the glacial ice that is on land. We're seeing the sea ice, it's been setting record lows in the Arctic, and that's also a few times in the last number of years, we're seeing record lows being set for Antarctic sea ice. So, this is a time of year, mid-March, where, we have the maximum extent of sea ice in the Arctic and the minimum extent of sea ice in the Antarctica, and they're both pushing on limits. It wasn't a new record in the Arctic, it was in Antarctica this year, and that contributes to the very, very large temperatures. When we don't have the ice and snow in the Arctic, then that heat, all the heat going into those regions goes into raising the temperature of the regions. And people have been talking just in the last year or more about the phenomena of atmospheric rivers, which are basically very, very long and very confined in the lateral direction. They're just like rivers in the atmosphere, very, very high moisture content. And that's being carried up to the Arctic in a number of cases. And also it's been happening in the Antarctic. But really what it boils down to is the jet streams becoming much, much wavier. They're extending much further in the Arctic, and they're extending much further north, going right up to the pole in the middle of winter when it's completely dark, bringing the temperatures above zero on occasion, and going as far south as the equator and actually crossing the equator. Now, in the southern hemisphere, the jet streams are generally stronger than they are in the northern hemisphere, but they've been slowing there significantly as well because of the polar warming, lowering the temperature gradient between the poles and lower latitudes. And it got stuck and created this heat dome, if you like, over the Antarctic. If you look at the maps of showing the temperature and pressure differences, et cetera, it's mind-boggling to meteorologists and to people that have been studying climate for many years. But if you consider the overall system, how the overall system has been changing and the rate at which it's been changing in the last several years, it doesn't really surprise me that these things are happening. And in fact, I've talked in the Arctic about the jet stream actually shifting location. Basically, the center of cold is what it rotates about, which is generally near the North Pole in the Arctic, offset towards Greenland. But with no sea ice, that center of cold will shift to about 83 degrees north, centered over Greenland. So that not only is it slowing down and becoming wavier, but it's also shifting where it's centered about. And a similar argument can be made in Antarctica. So, you really need to consider the different components and think of the Earth as a system where the equator is warm and the poles are generally cold, and that causes heat transfer from the equator to the poles, and it's done in the atmosphere, it's done in the ocean. And when we change the temperatures and conditions at either pole, and we've been focusing, like I say, mostly on the Arctic, but the Antarctic is doing a lot of surprising things now, then the whole system changes. It's like you're rewiring the way that heat is transferred and moved from one area of the Earth to another. So it's really important to consider the big picture which is behind all of these changes. And then that allows you to make predictions about what will happen. And it tells me, well, this is not a surprise. This is completely expected, that we're going to see more and more of these type of disruptions. And it's about time that, you know, the mainstream climate community and scientists realize this. Things can't always happen faster than expected. It means the expectations are completely wrong, which they have been for many years.
So yeah, this is really serious from everything that I've read and everything that I hear you saying, the both of you. And it's really hard to, I find, impress upon people the seriousness of this Arctic or this sea ice loss. I think it's because, for one thing, we live just so far away from nature. We're just not even in it. Even in our cities, wherever we are, we're just not in it. We're not in it, much less the Arctic. And it's just become so unrelatable. And a lot of people, they just don't get it. And some people I've even heard say, well, you know, it's great, you know, it's going to be a forested land and we can grow crops there. People even see it as maybe a net positive. I'm wondering, is there anything positive to this at all, or is it all just spelling disaster, Peter?
There's nothing positive here. People may mention that in some regions of the temperate northern hemisphere, the growing season has expanded a bit, but extreme weather events have been hitting the northern hemisphere food production regions, which are the best food production regions on the planet, very, very severely. We had excellent research team from near me, UBC, and also Toronto. And what they did was they did something very, very sensible. They looked at the extreme weather events over period years, and they gauged what effect that had, what immediate temporary effect that had on various regions of the world and all the food producing regions. And they were all hit pretty badly. There was a temporary sharp reduction. And then, of course, after the extreme weather events, it picked up again. But the big shocker on that was that the reduction was worse in our northern hemisphere best food production temperate regions than on the supposedly more vulnerable tropical and subtropical regions. So no, we should be reminded of the fact that the scientists told us decades ago to remember that the Arctic summer sea ice is the air conditioner for, quote, the entire northern hemisphere. So they've been saying for decades that we had to worry about our food productivity in the northern hemisphere by losing that sea ice. Now, there's a couple of other things which are more than a little alarming. The fires. We've got unprecedented forest fires now. It's pretty well right across the southern United States. 174 fires all at once. Texas has never had fires like this time of year ever. So could that be anything to do with the loss of sea ice to the Arctic? You better believe it could be due to that. So we are losing that sea ice steadily. And it's fast. It's very fast. What the scientists have not been very helpful, and Paul Beckwith was one of the first up on this. Everything that's happening, if you look at it over a period of 10,000 years, 20,000 years, everything is abrupt. Everything, right? This has not happened to the planet before. So the loss of Arctic sea ice is a dramatic, abrupt drop. The scientists, again, are misleading us on this one. The IPC says that the loss of Arctic summer sea ice is not a tipping point and it is not irreversible. That's absolute nonsense. It is, of course, as James Hansen warned us long ago, it's a tipping point that we've passed and we're going to lose all that Arctic summer sea ice.
Thank you, Peter, for bringing up the wildfires in Texas. And thank you so much for making the connection of what's happening in the Arctic with Texas. I mean, this is something that it's very, very difficult for people to fathom how these can be related. And I think this is why climate science is so hard to express and explain to people, and why it just gets so often lost in translation. I mean, we got to do a better job of trying to explain this to people. And as you were talking, I think, if I'm not mistaken, I think Paul might have mentioned the jet stream and how this will affect the jet stream, you know, the wavy gravy of the jet stream. I mean, I've even heard that with the loss of the sea ice that it'll affect the jet stream and there'll be more turbulence when we fly. So Paul, do you have anything to add to what I just said, or did you want to talk about the influence of the Arctic on the jet stream?
Yes, so they're tied intricately together because the jet streams exist in the first place because the poles are very cold and the equator is very warm. And that temperature difference plus the rotation of the Earth sets up the oscillating wave pattern that circumvents the Earth, both in the northern hemisphere and the southern. And the jet stream acts as like a wall between very cold and dry polar air and warmer, moist air from lower latitudes. This is true in both hemispheres. So as we're not in a world where the temperature just gets colder as you go further to the north or further to the south in the southern hemisphere. You know, that's the sort of world that we're used to, right? In general, you know, if you go closer to the equator, you're warmer, and closer to the poles, you're colder. But this is all thrown into chaos because of the waviness of the jet stream. Now you can have very, very warm, humid air going very, very far north to regions that used to be cold and dry, and you can get very cold and dry air going very, very far south. I mean, you're talking about Texas. Remember what happened when the trough of the jet stream went really, really low over Texas and got kind of stuck there. They had very, very cold conditions for weeks on end, and it took out, you know, large parts of the power grid, for example, because they didn't build the equipment to cold specifications. So when the cold and freezing came, it just knocked out the transformers and the grid basically went down. So our infrastructure, you know, our roads, our power systems, our plumbing systems, our fuel systems, you know, any of these connections that transfer something from one place to another, whether it be electricity or fuel or anything else, or people driving cars, right? Any of these transportation systems that are falling apart, they're breaking. And my immediate concern over the next, say, 5 years to 10 years is the global food supply. Our ability to grow food is being severely compromised by extreme weather events. And now we throw on top of that, throw in, you know, a Russian attack on Ukraine, a war, and Ukraine won't be able to export any of their food, you know, and they're considered the breadbasket of Europe, and their exports will drop down to zero, and Russia is not going to be exporting much food, and you know, people won't even want to, you know, get their food, right, with the trade embargoes and etc. Due to the war. So, you know, that's another big stressor on the food supply. And where climate change and these extreme weather events are causing cascading feedbacks, which exacerbate the problem. And I would fully expect that we're going to have global food shortages over the next 5 to 10 years at some point. And then all the scientists will say, well, we're surprised, we never expected this, right? So there you go. Just as what they're saying now about these temperatures in Antarctica and the Arctic. They really need to get out of their silos and look at the overall system and how it's changing.
They need to do that, and they need to do it quickly. And we have to find ways to communicate effectively. We just have to be more effective, I think.
Yeah,
know?
and I should throw in another wrench into the system. You know, we're in a La Nina, cooler period, and we're still setting these temperature record extremes. Wait till we go into an El Nino, where there's lots of heat coming out of the ocean into the atmosphere. And, all of these temperature records, temperature curves over time are just going to spike upwards with the next El Nino and blow away any heat records that we've seen up to now. So when this happens, how are we going to grow enough food in the food producing regions? It's hard to see how.
So Paul, I think you've come up with a great new show topic, because I got to tell you, you brought that up and I have questions now regarding La Nina and El Nino. So stay tuned, everyone. We may have another show coming your way regarding El Nino and La Nina. Very interesting topic indeed. And I want to thank you all for joining us. I feel as though this has been a really, really interesting conversation. I know that I got a lot out of it. I appreciated hearing from you, Paul, and from you, Peter. And those of you watching, if you got something out of it, please go ahead and hit the like, hit that little thumbs up, because it helps us with the YouTube algorithm. And if you haven't subscribed yet, please do, and share the video. And if you have any thoughts, please share it in the comments. We'd like to continue the conversation with you. So thank you, everyone, and see you next time at the Climate Emergency Forum.